Hey everybody, in this video we are looking at example 6 in lesson 1 with a focus on piecewise functions in our unit on limits. Here the directions are to graph and to find discontinuities, and we should be able to do finding the discontinuities both with and without graphing. So I'm going to start by doing it without graphing. So I just went over it in the last maybe 2 videos, so let's talk about what we do. So the first thing we're going to do is we're going to look at the type of function. It's a piecewise function, right? And we want to know if they have the same y value. If they don't have the same y value, especially also look at the domain, of course, but we're going until 0 and then we're starting at 0. So if they have the same y value and one's colored in, it's continuous. If they have the same y value and neither is colored in, it's removable or a hole. And if they have different y values, it's a jump. And 1 over x is a rational function, and x plus 2 is a linear. So in this case, we actually run into a situation where I have discontinuities in one of these functions, even without it being in a piecewise. So we have to really think about this a little bit in a little bit more depth. So over here, 1 over x, right, has an infinite discontinuity when x equals 0. And that's sort of where one graph leaves off. Y is 0, an issue for that function. We can't divide by 0. Well, what happens right next to it? So let's look at what we would do to figure this out. If we tried to solve this by doing what we did in the other examples, we're going to plug in 0. 0 plus 2 is 2. So my linear equation at the point 0, 2 has a closed circle over 0 up 2. What about the pink one? 1 over 0 is undefined. Again, x cannot equal 0, my domain. That's why we have a vertical asymptote at 0. So normally we would draw a vertical asymptote. Now some of you might not be like, well, it's not part of my domain, so I'm not going to draw anything for that graph there, but it doesn't really hurt to draw the asymptote because it's indicating it's not really a part of the graph, but it helps guide us draw the part of the graph right after 0. So, it still is beneficial. If I fill in 1 for 1 over x, the reciprocal function, I get 1. If I fill in if I fill in 1/2, I get 2. If I fill in 1/4, I get 4. Now, what's going to happen is you're going to get closer and closer and closer and closer to that vertical asymptote as you get closer and closer to 0. So even though you might think, oh, this looks like a jump discontinuity, it does, but it, I think, better qualifies as an infinite discontinuity. So let me just draw this a little bit better. So the blue one has a slope of 1. Now, a common mistake people do is they're like, oh, positive 1, and they go up and to the left. But if you go up and to the left, you're actually creating a negative slope, and that would be incorrect, right? So if what we want to do is 2 negatives make a positive. Down and left, negative, negative, that makes a positive slope of 1. And then for the pink one, we said it's going to get closer, closer, closer. Oh, I didn't want to use this pen. I wanted to use maybe like this. A little bit hard to see. No. Make this a little darker. So it's going to go up, up, and away. So now I know it kind of appears to be a jump, but it's sort of like rock, paper, scissors, right? Like what beats what? And it feels to me that we could clearly say that a infinite discontinuity beats a jump discontinuity, okay? It's much, much more intense. And there it is. So we have an infinite discontinuity at x equals 0. So I hope that this one made sense. I know it was a little funky and the graphing is a little bit more beneficial, but if it's a little bit okay, like you're kind of hanging in there, go ahead, show your happiness and give a thumbs up. If not, if you're like, this was terrible, I'm confused, give a thumbs down. Hopefully though you're happy. questions, comments, concerns, feedback, and requests, go in the comment section down below. Check the playlist and description box for more videos on this topic. That's it for now. Adios.